Hello class, welcome to Geometry Lesson 1-5, Conditional Statements. After this lesson, you should be able to write conditionals and biconditionals, as well as find their truth values. So let's quickly talk about what a conditional statement is. A conditional statement is whenever you have an if, then statement. So, if Miss Johnson is hungry, then she will eat lunch. That is a basic conditional statement. Now, whatever follows the word if is called your hypothesis. We talked about this in algebra, but it's been a while, so I'll refresh your memories. Anything that follows the word then is your conclusion. Okay? You'll hear me use the word conditional, hypothesis, conclusion throughout this entire lesson. So if you need to jot down a note to help you remember what those are, please do so now. All right. This lesson involves a lot of writing. So what I'm going to do is I have a lot of things already written out for me, and what I'm going to do is talk you through each thing. Okay, it's a little different than the normal video, but it'll make it much shorter for you to watch. All right, so example 1, write a conditional statement. So letter A, you can register to vote if you are at least 18 years old. So in order to write a conditional statement, you want to start with that if statement. So in this one, you're lucky, they already have the word if in their sentence. So all you have to do is write whatever follows the word if first. So if you are at least 18 years old, then you can register to vote. Done. That's all it's asking you to do. Then letter B, we have a square, a square must have at least 4 congruent sides. This time we don't have the word if and we don't have the word then. So I have to choose which part is going to be my hypothesis and which part is going to be my conclusion. So here I'm just going to start with the square as my hypothesis. So if a polygon, so if a shape is a square, then it must have at least 4 congruent sides. That is one possible answer for that problem. There are going to be a lot of different ways that you can write these answers. I can't possibly show you all of them. The video would be way too long and you guys would hate me a lot for it. So you might have answers that are a little bit different than mine, and that doesn't mean it's wrong. It just means that yours is slightly different. Okay? And if you're questioning whether it's right or wrong, be sure to ask for some help. Go ahead and write a conditional statement for the sentence. A triangle with all angles congruent is equilateral. Okay, so our conditional for this statement, I'm not going to write it out to save time, but if a triangle has all congruent angles, then it is equilateral. Okay, so I took the first part and I made that my hypothesis, and then I took the second part and I made it the conclusion. And while I was thinking through this problem just now, I realized this word should probably be equiangular and not equilateral. So, fake bonus points if you caught that typo. Okay, example 2. Find the truth value of a conditional. Okay, so I want to know, if I give you a conditional, can you tell me, is it true or false? So let's look at our conditional. If a number is even, then it is divisible by 2. Okay, so let's start with some even numbers. 2, is 2 divisible by 2? Yeah, that would be 1. 4, is 4 divisible by 2? 4 divided by 2 is 2, yes. What about 12? 12 divided by 2 is 6. 24. Okay, any even number is divisible by 2. So I'm going to say that the truth value of this statement is true. And the way we determined that was we listed multiple ways that it was true. So why don't you go ahead and find the truth value of this conditional. If a quadrilateral has a right angle, then it is a rectangle. Now, is this true or false? So we're talking about any four-sided figure. If it has a right angle, it has to be a rectangle. But maybe you thought to yourself, what about a square? That has a right angle, and that's not a rectangle. It's a more specific type of rectangle if you're remembering all of the relationships. But another example, we could have a trapezoid that has a right angle, and that's definitely not a rectangle. Okay, so trapezoid would be the better counterexample, but I know we haven't really talked about shape relationships a lot yet this year, actually really at all, so I would accept the square answer, okay? Now, this is a very important screen. I highly recommend you take a screenshot of it, and if you haven't already started a folder of geometry screenshots of important concepts, I recommend you start now and label them by whatever section we're in, so that way you can reference them later, okay? So let's talk through this table. We've already been talking about a conditional, right? It has a hypothesis that follows the word if, and a conclusion that follows the word then. And if I wanted to write it with symbols, so when I want to save time, I'm going to say if P then Q. So that is how you read those symbols out loud. You write a lowercase p, draw an arrow, and then a lowercase q, and out loud you say if P then Q. That is always the statement that you start with, okay? The conditional is what you start with. The converse is the same thing, except you flip the order. So instead of starting with whatever that first statement is, so let's see, what's one that we've already done? If you are at least 18 years old, then you can register to vote. That was our conditional. Our converse would be, if you can register to vote, then you are at least 18 years old. Okay, so notice I just flipped the order. That's all. Now, the word negation is when you change a statement to have the opposite meaning of the original statement. And the symbol we use is a little squiggle, okay? And you can read it as not P, you can read it as opposite P, or the negation of P, whatever you want. I'm okay with any of those three options, okay? So an example, if my statement is, Miss Johnson likes Chipotle, the opposite, or the negation of that statement would be, Miss Johnson does not like Chipotle. That's all it means. The inverse is when you keep the same order as the conditional. So we started with that P statement, ended with the Q statement, but you turn both of them into their opposites, their negations. And the contrapositive, if you look here, it's when you flip the order, so you start with Q, end with P, and they're both negated again. So if not Q, then not P, is how you would read the contrapositive out loud. So let's practice first with our conditionals and converses. So, sorry, I thought I put a screen shade on this one. Apparently I didn't. So just remember our conditional and our converse. Conditional starts with the P statement, ends with Q. Converse, you flip the order. So if my conditional is, if you play the saxophone, then you play a woodwind instrument. So I just underlined the hypothesis, and I'm calling it the P statement, and then I underlined the conclusion and called it the Q statement, okay? So if you play the saxophone, then you play a woodwind instrument. If I want to figure out the truth value of that, if you're not familiar with instruments, let me educate you. A saxophone is, in fact, a type of woodwind instrument. There are 3 saxophones right there for you to look at. I underlined them. Alto, tenor, and baritone sax. Those are all types of woodwind instruments. So that is true. The converse is when you flip the order. So if you notice, I changed the order down below. If you play a woodwind instrument, then you play the saxophone. Okay, so are there any other woodwind instruments that are not saxophones? Yeah. We have the flute, we have the clarinet, the oboe, we have the bassoon. We have lots of other instruments that are not saxophones, but are still woodwind instruments. So the truth value of that would be false, because I could list a counterexample. Okay? Now, I want you to write and determine the truth value of the converse of the conditional. So write the converse, and then tell me the truth value. And in case you don't remember what complementary means, complementary angles are 2 angles that add up to 90 degrees. Good luck. Hopefully for your answer, your converse, I'm not going to write it out to save time, I'm just going to say it out loud, would be if two angles add up to 90, then they are complementary. That would be your converse. If two angles add up to 90, then they are complementary. Now, is that true or false? That is actually true. If two angles add up to 90 degrees, then they are complementary. That is indeed true. Okay? Example 4, write and evaluate the truth value of the inverse and contrapositive. So let's start with our conditional. If two whole numbers are both even, then their sum is even. Sometimes it helps to write down an example of what it means when it's maybe not as easy to picture. So if we have two whole numbers are both even, so I could say 2 and 6, then their sum is even. So sum means I'm going to add, and that would give me 8. Is that true? I have two whole numbers I'm adding together, and their sum is even. That is true. Okay, so I'm going to keep going. Now, remember the inverse is when I keep the order the same, so P first, Q second, but I negate it. So my new statement would be, if two whole numbers are both, I could say not even, or another word for not even would be odd. So I'm going to use odd. If two whole numbers are both odd, then their sum is odd. That would be my statement. And is that true? If two whole numbers are both odd, so let's say I have 5 and let's say I have 3. Those are both odd numbers, right? Then their sum is odd. So if I add that together, I get 8. Is 8 odd? No. So this would be false. And that would be a counterexample. So let's look at the contrapositive. First we start with the statement Q, and then we go to the statement P. And remember, both statements are negated. Okay. So our new contrapositive statement would be, if two numbers have a sum that is odd, then the two whole numbers are not both even. Okay. So a couple examples of that. I'm looking for a sum of 7. Okay, so that meets the hypothesis, right? A sum that is odd, 7 is odd. Then the two whole numbers are not both even. So if I do 1 plus 6, I have 1 odd, 1 even. 3 plus 4, 1 odd, 1 even. 2 plus 5, 1 even, 1 odd. So there we go. That would be true. All right, so let's now look at question number 4. I want you guys to come up with the inverse and the contrapositive statements as well as the truth values for each. Okay, so hopefully for the inverse, you remembered you keep the order the same but you negate it. So if today is not a weekend day, then tomorrow is not Monday. That would be true. And the contrapositive would be, if tomorrow is not Monday, then today is not a weekend day. And that would be false, because if it's Saturday, that's another weekend day, and the next day is not Monday. So Saturday would be my counterexample. All right, example 5, let's talk about biconditionals. So we want to write and evaluate a biconditional. So first of all, a biconditional is the combination of two different conditionals, okay? So the conditional and the converse. The resulting compound statement is read as if, or P, if and only if Q. Now, I know we're doing a lot of writing today, so I'm going to teach you a shortcut. Instead of writing if and only if, you can write I, F, F. However, if you're going to use this, make sure you don't forget that second F, because if you're talking about a biconditional and you just write if, IF, I'm going to mark it wrong. You need that second F for an if and only if. Same thing goes for if we're talking about just a regular conditional and you use IFF, I'm going to mark it wrong. So be careful with that usage if you plan on using that little shortcut. Okay, so let's talk about a biconditional. So we have our conditional and our converse listed here. Our conditional is if a seahorse gives birth, then it is male. And our converse is if a seahorse is male, then it gives birth. Okay, so our biconditional, I'm going to say my P statement is a seahorse gives birth. My Q statement is it is male. So my biconditional is going to be a seahorse gives birth if and only if, I'm going to use the shortcut there, if and only if it is male. That is all I have to write for my biconditional. Now, in order to figure out the truth value of a biconditional, I need to look at the truth value of the conditional, and I need to look at the truth value of the converse. So let's figure those out quickly. So the conditional, if a seahorse gives birth, then it is male. That is true. Male seahorses are the only ones to give birth. Converse, if a seahorse is a male, then it gives birth. That's going to be false because there could be a male seahorse that does not give birth. Okay? Now, let's talk about the truth value of the biconditional. In order for a biconditional to be true, the truth values of the conditional and converse have to match. So you need either two truths or two false. So here we have one of each. That means our truth value is false. All right, I forgot to put a screen shade on this one too. So since this video is already getting long, let's just talk through this question. If I asked you to write a biconditional for the following conditional and converse and figure out the truth value, if we look at the conditional statement, I underline everything that's after if, that becomes my P statement. Everything after then becomes my Q statement. My biconditional, I start with the P statement. Two lines intersect at right angles. If and only if, then the Q statement, they are perpendicular. Now the truth value of those, the conditional would be if two lines intersect at right angles, then they are perpendicular. So my conditional is true. My converse, remember I just flipped the order. If two lines are perpendicular, then they intersect at right angles. That is also true. So I have two truths, which make a biconditional truth value of true, because my truth values match. All right, example 6. This is our last example for the video. What are two conditionals implied by the biconditional? So I have a triangle is equilateral if and only if it has three congruent sides. Okay, I'm going to say this is my P statement, and this is going to be my Q statement. So my conditional, I'm not going to actually write this out, but my conditional would be if P then Q, which would sound something like this. If a triangle is equilateral, then it has three congruent sides. My next conditional statement would be the converse of that, which would be if Q then P, which would be read, if a triangle has three congruent sides, then it is equilateral. Okay? I do expect you guys to actually take the time to write those out as you practice. So when I ask you to do question number 6, make sure you write out the answers. I'm abbreviating to help make the video a little shorter. All right, go ahead and write down the two conditionals implied by this biconditional. The product of two numbers is negative if and only if the numbers have opposite signs. Hopefully you ended up with two conditionals that look something similar to what I have. If the product of two numbers is negative, then the numbers have opposite signs. And if two numbers have opposite signs, then their product is negative. The last thing I'm going to highlight for you guys is this concept summary. Make sure you memorize everything in this table. You will see me use all of those symbols. You will hear me say all of those words. So you need to make sure you know what I'm saying when I say it both in class and on a test, okay? So make sure you screenshot that, save it somewhere, make sure you study that. If you have any questions at all, please feel free to reach out for some help. I'd be more than willing to assist you. Have a great day.